Bismillahirrahmanirrahim. Today is lecture 5, and in this lecture, we'll talk about the highway curves. And the first curve we normally discuss is a horizontal curve. So, what is a horizontal curve? This is a curve provided on a highways whenever there is a change of direction, and it actually assists the vehicle in negotiating a turn. So, larger the radius, the larger the vehicle, the larger will the curve we need to provide, and the smaller the vehicle it is, the smaller we can provide. So another definition could be when two tangents meet at some angle, obviously less than 180 degree, we need to provide a curve. Ideally it should be 90 degree, but it can be anything between 0 to 180, less than 180, right? So a single curve, there are different types of a curves. A simple curve, a single curve having radius from start to finish. The simple curve is an arc of a circle. It is most commonly used. The radius of the circle determine the sharpness or flatness of the curve. The larger the radius, the flatter the curve. Compound curves, two curves having different radii are called compound curves. The curves are often used because of the tearing condition. These curves normally consist of two simple curves curving in the same direction and joined together, like this in the figure. Then there is a reverse curve. A reverse curve consists of two simple curves joined together but curve in opposite direction. For safety reason, these curves should not be used unless absolute necessary, but this is only guidelines. In a terrain like mountainous terrain, these curves are not avoided, and it cannot be avoided practically. Then there is a broken back curve. Now this is the type of the curve usually don't provide. Instead, we provide a spiral curve. Broken back curves should be avoided if possible. It is better to replace the curves with a larger radius circular curve. Then there is a spiral curve. The spiral is a curve with varying radius used on railroads and highways. It provides a transition from tangent to a simple curve or between simple curves in a compound curves. Spirals are typically placed between tangents and circular curves to provide a transition from normal curve to a superelevated curve. Spiral, Spirals are typically used at intersections to increase the room for a large trucks to make turning movement. These are spirals. This is a curve and this is tangent. So anything between tangent and curve is a spiral curve. It has infinite radius at one end and it has radius equal to circular curve at the start of the curve. Same bone behind, then again there is a radius, curve radius at this point, and it gradually largens to give the tangent. Now, curves are divided at different segments, and these segments are known as element of circular curve. Using this element, a circular curve can be set out. Now, if you look at this figure, there are different elements that are being designed, and we go and explain this one by one. So, if we look at this curve, there is a back tangent, a line, road going this way, and a road going this way. So, this is they are intersecting at point pi. So whenever the road is intersecting, this line intersecting this line, we provide a curve from PC to PT. Now this will have different denotation. For example, delta is central angle, then D is the deflection degree of curve, then small d is the deflection angle, and all all of thing will be defined uh, in a order. For example, when we start the curve, there is always stationing. So we say on route surveys, the surveyor numbers the station forward from the beginning of the project. For example, 0 plus 0, 0 indicates the beginning of the project. The term 15 plus 52.96 would indicate a point 1552.96 feet from the beginning. A full station is 100 feet or 30 meters, making 15 plus 00 and 16 plus 00 means a full station because the difference between 15 and 16 is 100. A plus sign indicates a point between full station. So 15 plus 52.96 is a plus station. When we use this metric system, the surveyor 15 plus 520 means 15 kilometers and 520 meters. The station number simply becomes the distance from the beginning of the project. Simple as that. So the point, this point PI, what is a PI? This is a point of intersection, marks a point where the back and the forward tangent meets. In the figure, T1V is a backward tangent and T2V is a forward tangent. Then there is an intersecting angle. The intersecting angle is the deflection angle at the PI. Its value is computed from value from preliminary transverse station angles or measured it in the field. Then radius. The radius is this point between 0 to T1 or 0 to G or 0 to T2 is the radius of the circle which the curve is an arc. Then there is a point of curvature, or we call the point of commencement of curve, and it is simply the point where the curve begins, like here T1. We call this as PC, and then there is always the end of the curve. This point of tangency is the end of the curve, and this is the forward tangent to the curve at this point. Another terminology is length of the curve. The length of the curve is the distance from PC to the PT in a arc, along the arc. Because there can be a distance along the chord, so this can be known as chord length. But when I say curve, I mean the length along the arc. So actually the length on the curve is more than the length on the straights. That's why it should be differentiated accordingly. So the long chord is the chord from PC to PT measured along the curve. Then there is a tangent distance. The distance is the distance along the tangent from PI to PC or PT. These are equal on the simple curve. So that this distance PC and PI is tangent T or PI to PT, and they are equal in length on a simple curve. Then there is an external distance. The distance is the distance from PI to the midpoint of the curve. The external distance bisects the interior angle at the PI. So this distance from this point to this point is E, or we called, because from the peak of the curve to the intersection. Then there's mid ordinate. The middle ordinate is the distance from to midpoint from the curve, from the midpoint to the midpoint of the PC and PT in a long chord. The extension of the middle coordinates bisect the central angles. What I mean is this distance between this point to this point is mid-ordinate, and if I extend this to a point O, then delta will be divided by delta by 2. So, but what is delta? Is a central angle, is the angle formed by radii drawn from center of the circle. The central angle is equal to the value of the eye angle. This is the deflection angle. What I mean here is this is the central angle, and it is between the two lines of different height. This is radius, and this radius are joining the curve. So this angle is known as deflection angle or central angle. This is deflection angle, but numerically, deflection angle or intersection angle is same as the central angle. So, so some people this uses this I, some as delta. Then there is a degree of the curve. The degree of curve defines the sharpness or fretness of the curve. There are two definitions commonly used for degree of the curve: arc definition and the chord definition. In the arc definition, degree of the curve is the angle formed between the two radii from the center of the circle, and this arc length is taken as 100 feet. And the chord definition is the angle formed by two radii drawn from the center to the ends of the 100-foot long. So this actually the angle between the chord is a chord definition, and the angle between the curve is the arc definition. Normally in highways we use the arc definition, while on railways we use the chord definition. So we continue with the chords. On curves with long radii, it is impractical to take out the curve by locating the center of the circle and swinging the arc with a shape. The surveyor lays these curves by sticking the ends of a series of chords. Since the end of the chord lies on the circumference, the surveyor defines the arc in the field. The length of the chord varies with the degree of the curve. Now, to reduce the discrepancy between the arc distance and the chord distance, the surveyor uses the following chord. So, if you have degree 1 to 3, you will use 100-foot chord or 30-meter chord. If you have 3 to 8 degree, you will use 50-foot chord length and 15-meter length. If you have higher degree of curve, then you will go, the chord length will be 25 feet and the length meter will be 7.5. And if you have a degree of curve greater than 60, then the chord length will be 10 and length will be 3. This chord length will be defined to you actually in the last part of this lecture. So these are normally the equations used to define properties of the curve. Length of the curve 100 I over d, or you can say 100 delta over d as well. I and delta can be used as a synonym here. Then the radius 5729.58 divided by d. External ordinate r 1 over cos I by 2 minus 1. This can be also E is equal to tangent t tangent delta over 4. M is E over cos delta by 2, or M is equal to R 1 minus cos I by 2. Length of the chord is 2 R sine I by 2. Now, how you arrive these relations? Let's see. First of all, when I say central angle is equal to intersection, how we can prove that? Now, consider chord A, B, K, O. Since it's the chord, therefore the sum of all the angle A, angle B, angle K, and angle O should be 360. Remember, angle A and K are 90 degree because there is a tangent here and the tangent here. Similarly, if this is the intersection I, this angle will be 180 minus I, because this is 180, this I, so 180 minus I, and this is delta. So angle A is 90, angle B is 180 minus I, angle K is 90, and then plus delta, this should equal to 360. And if you just add this thing, put it there, you will find delta is equal to I. That's why the intersection angle in a simple curve is same as the central angle. That's why sometimes you will find in books there is I, in other books you will find delta. Other logically it is same as I have shown. The second relation that is also important is how to know the relation between degree of curve. Just a simple thing. We say if D is the angle between 100 feet, so the maximum D could be 360. So we say D over 360. And if D is defined for 100 feet arc, 360 should be defined for whole circle. That's why the length of the arc for a whole circle is 2 pi r. So we have used simply this relation, and if you solve this thing, this become radius is 5729.58 over d. Remember, we are using the foot unit. If you would have used this metric units, this will be 30. So that will change now. D over 360 is equal to 30 over 2 pi r. So conversely, if you solve that, it could be r is equal to 1719 meter. In other words, if I want to convert this in meter, just divide by 3.208, and this I will get the same value. The third relation is called the length of the curve. This is point between this point to this point. Again, we will use the same relation. That is length of the curve over delta, and the length of the total curve is 2 pi r, and the total length, this angle is 360. So length of the curve is simply pi times radius delta over 180. Then length of the tangent, this point T. So distance between A and B is tangent length. And if I consider this triangle BAO, this is a right angle triangle. Now this is T upon R is tangent theta, and theta is delta by 2, as you can see from this figure. Simply tangent is r tangent delta by 2. So if we want to know this tangent length, we must know the value of central angle. Obviously we divide it by 2, and we also know the radius. We'll find tangent r tangent delta by 2. I hope I'm not going too fast. It's a very simple geometry and you can understand very well. I hope. Then the length of the chord. Now you know that any line joining 2 points along the curve is a chord. We call this as a long chord. Now, in order to find the value of length of the curve, what we have done is I've taken this triangle AGO. Again, this is a right angle triangle. So this is what? This is perpendicular L chord upon 2, and this is hypotenuse R. So we know that perpendicular of hypotenuse is sine theta, and sin theta is delta by 2. So now we know that length of the chord is 2r sine delta by 2. Then there is an external distance. This can be determined by using this triangle BAO. This is a right angle triangle. The distance of hypotenuse is R. Now this is the base R, and this is hypotenuse R plus E, as you can see in this figure. So R plus base upon hypotenuse is cos delta by 2, and if we solve this, you will find E is equal to R sec delta by 2 minus 1. Now the mid distance. Mid distance, for mid distance we will use this triangle, that is AGO, and just using simply the mathematic equation, that is sine theta or sine del cos theta is base. This base is r minus m. Hypotenuse is r. So r minus upon m upon r is cos theta. And if you solve this thing, you will find the value of m is equal to radius 1 minus cos delta by 2. Now, now the changes of the tangent point, we see the BC is simply, now if you see this BC, if I know pi, if I subtract this distance t, this is t, then I will come PC. And if I add length of the curve for now PC, this is PT. Now let's solve one problem in which we know how to calculate the curve parameters or element of the curve for the given data. Now here a straight line meets another straight line. So whenever the two line meets, a curve is formed. It has a station pi having value of 6 plus 263.57 and having a deflection angle 16 degree 38 minute. The curve has a radius of 300 meter. Compute the degree of the curve, tangent distance, length of the curve, chord distance, middle ordinate, external ordinate, PC and PT. It means all the relation you have derived previously you have to calculate here. Now, so I have delta 16 degree 38 minutes. I can always find degree of the curve because the radius is given to me. Now remember, these we had calculated in fits, but since we are all units are in meter, that's why we say this as meter. So we'll use 1718 divided by r. So we'll get degree. So what degree of curvature is found? Then they say tangent distance. T is equal to R tangent delta by 2. R is known to me, delta is known to me, so that's why T can be find out. Length of the curve. Length of the curve is pi r delta over 180. Again, all of them are known to us. That's why we find the length of the curve is 87.10 meter. Then, then there is a tangent. Okay, then there is a length of chord. Length of chord is 2r sine delta by 2. So just plugging the value will get 85.23. Then External ordinate, it was given as like this, r1 over cos delta by 2 or sec delta by 2 minus 1. So we'll find this as 3.19 meter. Mid ordinate, it was r1 minus cos delta by 2. So again, plug the values, you will get this answer. PC is pi minus g. Pi is given to me. What was 6 plus 263.57? Remember, we have to remove this sign. So this becomes 6,263.57 meter. Or in other words, it is 6 kilometer, 263.57 meter. Nevertheless, by solving, just forget plus like here. So 6263.57 minus tangent length, this is 43.85. Then point of tangent, this is pi, again 6263.57, and then the plus this length. The length of the curve is actually 87.10 meter. I'm sorry because I misunderstood. Actually, I mistakenly length of chord is length of the curve, but you will add 87.1 rather than 85.23. So you see, solving a circular problem is very simple. Now, the last topic of this lecture is uh, you have to set out the curve on the field, and the method is known as deflection angle. So you can always prove this thing mathematically as well, but I'm taking this as you know that. So if there is a small angle delta A, you can always find this by knowing the chord length over 2r, and then it's very simple. And if you add all those delta A, you will find the total deflection angle is delta by 2. Now, what I mean this CA, that was the CA that I was defining in this table. That if there is degree of the curve between 1 to 3, you will have CA is 30, and it varies between what you have defined for different degree of curve. Now, there is a problem. Oh, sorry, not a problem, this is a numerical. The center line of two straight is projected forward to meet at I. The tangent deflection angle is 30 degree. If the straights are to be connected by a circular curve of radius 200 meter, tabulate setting out data assuming 20 meter chords on a through chainage. The chainage of delta being 2259.59 meter. That I mean is the chainage of the PI is given to us. So let's solve. The tangent length is the R tangent delta by 2. So we know this 53.59. The chainage of PC is chainage of PI minus tangent length. That's how why we have got this value. Length of circular arc is pi r delta over 180. So we find 104.72 meter. And the chainage of PT is just this chainage of PC plus length of circular arc. Here I've got it right. So PC 2002 plus length of the curve 104. We'll find this as 2306.72 meter. Now, how to solve this equation? So how to set out this curve? So we make a table when we start with the chord station, then the chord length, CA, you can see the chainage, the starting point. We calculate the curve deflection by using this relation. Delta A is equal to sine inverse CA over 2R. Remember, CA is 0 here. It is 18, 20, 20, 20, 20, 20, and then the last thing. Then we accumulate all this angle and see that last one should be equal to delta by 2, and there is a remarks. Now, so first thing what you do, if you want to have 20 meter, then the first chainage, obviously we start at this point, so there will be no length, this starting point. That's why you will find all these values 0. But the next station will have a chord length of 18 meter because we want to round this is as 20 meter. So the next 20 meter from this chainage will come as 2220. If I could have taken as 10 meter, then this will be 2210. So you have first, and if this would have been 2216, then again you will have gone from 2220. So first chord length may not be equal to the chord length that was you asked for. Actually, we want to round the other thing. So now the chord length is 18. So if I just plug 18 and R, I know 200, I will find this angle as 2 degree 34 minute and 42 seconds. Now if you complete it, I will add previous angle to this angle, I will get this cumulative value. Now the next station, since this is 20, the next station will be 2240. We'll keep on doing it until we reach the last station. So then 2260, 2280, 2300, and we cannot have 2320 because the last station is 2306.72. Now, so again, the difference between two decisions 20, 20, 20, and last but not least is 6.72. Because the difference between 2306.72 minus 300 6.62. And what you do, you subtract, to get this value, subtract forward value from the previous value, so we'll get this 20. That's how we'll have this value. Now, since CA is 20 in all of this, that's why will not calculate this value. And until and unless CA is changed, since CA is changed in first and last value, so we have, sorry, second value and third value, last value. So if I uh, put the value of 6.72 here, I will get this 0 degree 57 minute 45 seconds. Now we will add consecutively to get the cumulative deflection angle. 0 plus 234, 234, 234 plus 251, 526, 526 plus 251, 817, 817 plus 251, 1109. These are the pegs. And then 11079, 1401, and 1401 is 057. This makes 1459.29. And if I round it off, this becomes 15 degree. And so that's the last set of setting out angle should be equal to delta by 2. So this ends my discussion on lecture 5 on circular curve. I hope you have understood. We'll have next lecture on other types of curve such as compound curve, circular curve, and spiral curve. So take care and Allah Hafiz.